Muscles and nerves are some of the most incredible structures in the human body. Like, just look how cool the largest nerve of the body is, this nerve hiding underneath the hamstrings called the sciatic nerve. So today, we're going to do some rapid fire anatomy to see how much you know about your own body, but also to show you some of the coolest nerves and muscles, as well as show you some of the instances when nerves can get crunched or compressed and then not work properly. And of course, throw in some other random but anatomically important structures. So let's buckle up for this anatomical awesomeness. What I'm about to show you is a really amazing network of nerves, and to do that we have to reflect the chest muscle called the pectoralis major, as well as the smaller pec muscle, the pectoralis minor, and then you can see these cords which make up this amazing network of nerves, and they come up all the way out of the neck, and this is called the brachial plexus. This network of nerves will have 17 different nerve branches coming off of it to control muscles like the pec muscles, the biceps, and many other of your upper limb muscles. You are looking at a cross section through the upper thigh, and you can see a lot of cool anatomy here, like the femur and how the shaft of the femur is hollow. You can see the femoral artery, and you can even see groups of muscles like the quads here, the hamstrings would be back here, and even this medial mass here is the adductor compartment. But what I want to really focus on are these connective tissues that wrap the muscles. Like, here is the fascia, which wraps a group of muscles. It's a dense, irregular connective tissue that wraps a group of muscles. But if you look closely, you can see this thinner white line here, and these white lines that are thinner are representing the epimysium. Epimysium wraps individual muscles, so you could tell the difference between, say, like the vastus lateralis versus the vastus intermedius. And even see something like the adductor longus over here. So our muscles are wrapped in groups with fascia, and then individually with this epimysium. When most students first see this dissection of the upper anterior thigh, their eyes almost always go to the femoral artery as well as the femoral vein. For good reason, they're pretty cool structures to look at. But sometimes they'll be so excited that they won't pay much attention to this femoral nerve. Now, this femoral nerve will innervate the muscles of the anterior thigh. So that would include the 4 quadricep muscles and even the sartorius and a couple others that we'll save for another video. But let's say I could use the force, like the dark side of the force, like Darth Vader, and compress your femoral nerve here and squish it down. What would be your biggest symptom? Well, the most noticeable symptom would be that you could not extend your knee because your quadriceps wouldn't be working properly. And so therefore, you couldn't, say, like stand up from a squatted position. At some point in your life, you have probably overstretched or damaged these ligaments around the ankle when you've rolled your ankle. Some of you may have also experienced some pain up in these muscles called the Fibularis muscles, sometimes also referred to as the peroneus muscles. This is the peroneus longus or Fibularis longus, and underneath, if I can get my probe underneath there, this one hiding underneath is the peroneus or Fibularis brevis. Now, what happens is these muscles will actually evert your ankle, but when most of us roll our ankle, we invert it or hyper-invert it, which would overstretch these muscles and also overstretch or tear those ligaments. So not only can you get pain down here with an ankle sprain, sometimes you'll feel pain up in these muscles due to that overstretch. You are looking at the backside or a posterior view of a left thigh, and let's talk about the hamstring. First, how did it get its name? Ham refers to hollow or bend of the knee, and string because you can feel those string-like tendons on the back of your knee. Now, the hamstring is actually 3 muscles, and we've got the first one called the biceps femoris. Biceps refers to 2 heads. We've got a long head here and then a short head here. Then we have the semitendinosus, and you can see why it got its name because of that cylindrical tendon down here. And this tendon of the semitendinosus will sometimes get used as an ACL graft for someone who tears their ACL. And then we've got the semimembranosus, and again, you can see why it got its name because of that membranous tendon that it has. Now, the hamstring muscles, these 3 muscles, will act to flex the knee as well as extend the hip. For those of you that have watched our channel before, you may notice that I'm wearing a different t-shirt. And for those of you that are new, I pretty much wear the same t-shirt in every single video. Well, not the exact same t-shirt. I have 5 or 6 of the same print that I rotate through. I do have some cleanliness standards here, but regardless, we thought it was finally time to create our own line of clever anatomy t-shirts, such as this one, Be Kind to Your Mind. And yes, this is actually one of the brains that we have here in the lab. And we have all sorts of other prints, from reproductive t-shirts with inspirational messages, to nerdy anatomy t-shirts and IOHA support shirts, and even Jeffrey the Skeleton has his own personalized line
of prints. So, if you want to have some anatomically awesome merch, be sure to click the link in the description to check out our store. And now, back to rapid fire anatomy.
What if your biceps was paralyzed? Well, let me tell you about an interesting case study that was given to me as a student. There was a college athlete that came into the clinic and his biceps was pretty much paralyzed, along with the muscle underneath called the brachialis. And when they tested his elbow flexion, or the ability to bend his elbow, it was greatly weakened because these muscles weren't functioning, and so he only had a few of the accessory muscles to help with elbow flexion, so it was greatly weakened when compared to the other side. And what they found was that this nerve, called the musculocutaneous nerve, was being compressed by the smaller muscle underneath the biceps called the coracobrachialis. If I slide this out of the way, you can see that nerve piercing right through that muscle. And they found that he'd been overtraining and this muscle got inflamed and crunched down on the nerve so it couldn't send the signal to the biceps or that brachioradialis. And he even had some numbness in the lateral aspect of his forearm. So he had to rest this poor little muscle to gain his full function back. So let's take a look at this beautiful muscle that we call the pectoralis major and talk about how it functions and why we pick certain exercise choices like the push-up or the bench press to work it out. You can see it's attaching to the sternum here, coming up off the clavicle up here on that clavicular head, and then you can see these fibers converging onto the humerus. For you anatomy nerds, it goes and inserts into the intertubercular groove. But when these fibers contract, it will pull on the humerus and cause
the shoulder joint to move forward like this, and we call that flexion of the shoulder. And it actually even works more effectively, or at least fires more into the muscle, if you start in more of a hyperextended position and work it that way. But some of you might be thinking, well, I don't really go to the gym and work out my pecs this way. Well, some people do. They'll actually grab cables and do flexion of the shoulder this way, but most of us will do the push-up or the bench press, and you can see it looks different, but I actually end up in the same place. The difference is I get my elbow involved, as well as, therefore, the triceps muscle, making it a compound movement and a little bit more bang for buck, if you will.
I want to show you this really cool connective tissue band called retinaculum. Specifically, we're looking at the back of the wrist, and this is an extensor retinaculum. And if you look closely, you can see those fibers are running perpendicular to the direction of the tendons. And many of these tendons will make it all the way down to the end of the fingers. And we need this extensor retinaculum because every time you extend your wrist, if you didn't have that retinaculum, the tendons would start to bulge out of the skin, creating like a tenting in the skin, and let's be honest, that would look really awkward. So we recently had a question about if veins are flat, why are they sometimes described as rolling? Well, first, I wouldn't actually describe veins as flat. Now, these ones are technically flat because there's no blood inside of them, but veins are actually hollow little tubes with blood inside, so they are round and hollow. And so when you talk about a rolling vein, that's not really a technical term or a diagnosis. It's kind of this phrase to describe when somebody injects a needle, that the vein is a little bit more mobile in that person and it can slide around. So when the needle goes in, sometimes it pushes the vein to the side and you miss that needle stick. Now, a rolling vein could potentially happen in any person, but they're a little bit more common in, say, elderly people where the connective tissues that actually hold the veins in place are a little bit weaker. Let me show you something really awesome about your trachea or your windpipe. But just to orient you, if you've never seen this before, this is your larynx or your Adam's apple. And posterior to all this is the esophagus or the food tube, which will transport food down to the stomach. But if you look closely at your trachea or your windpipe, you can see these cartilaginous rings stacked on top of each other. Now, they're not full rings. They're actually more like the letter C. They don't come back to get fully together in the back. And this fibromuscular membrane and the fact that these cartilaginous rings don't come fully together do allow some change of shape for your windpipe when you're inhaling and exhaling, but they still provide enough rigidity that your airway won't collapse, especially when you're sucking in air or inhaling deeply. This muscle is a muscle that many people don't like to work out in the gym unless they've got a mirror in front of them. This is called the trapezius. A lot of people nickname it the traps, and they do shoulder shrugs in front of the mirror in hopes that they can really get this part of the muscle to bulge or hulk out, if you will. Now, the funny thing is this muscle doesn't actually even move the shoulder joint. When we shrug our shoulders, we actually do something that's called elevation of the scapula. This bone here just goes straight up, and then the shoulder joint actually just comes along for the ride. Now, this trapezius muscle does a lot more than just elevates the scapula. It can actually extend the neck. It can even bring the scapula inward, which is called retraction, and even twist the scapula upward into upward rotation. So let's take another look at this little flappy doodad structure that we call the epiglottis. Clearly, flappy doodad is a technical term, but the epiglottis is made out of this elastic cartilage. And what happens is when we swallow, the larynx or the voice box will elevate or move upwards, and this will flap down and close it off so that food and water can go down the food tube or the esophagus rather than down the respiratory passageways. And if that happens, we've all had our little dysfunctional moments and we kind of cough up a lung, so to speak. Now, I just like to show another view of this because this one hasn't been cut in half. You've got the trachea and even the esophagus behind it, and there's that epiglottis. This is about how it would compare to this dissection. But one thing that's cool is just to see inside. You can see the airway that the epiglottis would block off versus the esophagus or that food tube.
So hopefully you learned some new information in today's video, but let us know how you like this rapid fire style of an anatomy video in the comments below, and let us know what your favorite structure was that we covered today. Either way, thank you for supporting the channel, and it will make my atrial chambers flutter in a good way if you like and subscribe and maybe even check out our merch store. And of course, Jeffrey and I will see you in the next video.